So far, all the integration we've looked at is what we call an indefinite integral. So an indefinite integral is where we have this type of situation. We've done lots of those over the last few days. What we want to do now is turn our attention to what we know as the fundamental theorem of calculus. Doesn't mean much to you, but what it basically allows us to do is evaluate what we call a definite integral. So these are indefinite integrals, and we're going to look at definite integrals. Now, basically, definite integrals is where we put numbers on our integration symbol, and what it basically states formally is if the function of x is a continuous function in the interval between a and b. So basically, it's a function that keeps going between a and b. It doesn't stop. It doesn't break. It's all good there. So fx is the primitive. So is the integration of the function of x. So capital Fx is the primitive there. And if we have that, then what we need to do is basically say, well, we're going integrating from a to b of the function of fx. We integrate that. We sub in b, and then we take the integral of the function of x and sub in a, and that's when we're going to find a value as such for our integration. So we put something, getting the derivative, the integral, and then subbing in two values that are on the boundaries of the area or whatever we're looking to find. Notice here we don't have to worry about a constant of integration, really, because once we include a constant of integration with a definite integral, they get cancelled out. So we don't have to worry about a constant with these ones. So let's have a look at what we mean. So if we're going to integrate the function of x squared with respect to x between 0 and 2, well, the first thing we need to do is integrate it. So we integrate, we get add 1 to the power, divide by the power. Now, our notation is usually to put the square brackets, okay, which are actually what we would call brackets, and we have the 0 and 2. Now we write it in this one, so the lower limit and the upper limit of our integral there. And then what we're going to do is substitute in. So we're going to be looking at 2 cubed over 3 minus 0 cubed over 3. Well, that's going to give us 0. And we're going to get 2 cubed on 3, which is going to give us 8. We usually like seeing 0 as one of our limits because it starts to make life a little bit easier. Most of the time, not always, but most of the time it does. So let's examine this example. We're integrating between 1 and 4, the function 3x squared dx. So we add 1 to the power, gives us 3. We divide by the new power, which is 3. And we can clean it up and say, well, the 3 divides with the 3 there. That just leaves us x cubed, and leaves us to sub minus 1 and 4 in. So we get 4 cubed, because we sub 4 in, and we sub 1 in. So 4 cubed minus 1 cubed would give us 63 in our calculation. You can throw it in the calculator if you want. So integrating between 2 and 5 of 8x. Again, add 1 to the power, so it gives us 8x squared over 2. Again, we can clean that up, and it's just going to give us 4. So 4x squared between 2 and 5, so we substitute 5 in, and we substitute 2 in. So doing our calculations will give us 100 minus 16, which gives us 84. Question 4, we integrate 5x to the power of 4, so we add 1 to the power, divide by the power. Nice examples because we're getting rid of our coefficients there. When we do that, between 2 and 6, so we write our 2 and 6 down there, and we get 6 to the power of 5 minus 2 to the power of 5. Do our calculation, give us 7,744. X cubed, dx between minus 3 and 3. So we add 1 to the power, divide by the power, between minus 3 and 3, so we substitute the values in. So 3 to the power of 4 over 4, and minus 3 to the power of 4 over 4, gives us the same thing, which means it's 0. So we'll talk about this a little bit later on, but if we've got an odd function and our limits of integration are exactly the same except opposite in sign, our answer is always going to be 0. So if you know that for a fact, that you can tell that's an odd function and you've got that situation, all this working is null and void. You don't have to do it. You could automatically say, I know it's going to be 0, because of the fact that it's an odd function and the limits of integration are the same but opposite in sign. So keep that in mind. We will talk about a lot more with our areas and other applications there. So in 6 we've got x, we're going to add 1 to the power, divide by the new power as well. So we had 3 on the bottom, so we've put the 3 times the 2 on the bottom. That's why we got the 6. And we're going between 0 and 3, so we substitute 3 in. Gives us 3 squared on 6, and substitute the 0. Well, that's going to be 0, so that's nothing. It's not going to work out to be anything there. And 3 squared on 6 gives you 9 on 6, which comes down to 3 on 2, so you can clean it up that way. 3x cubed gives us the 3x power 4 over 4. We're going to integrate between 1 and minus 1 and 2, so we substitute 2 in, and we substitute the 1 in. Be really careful with your values and subbing them in and how you put them into the calculator. So we get the 12 minus 3/4, which will give us what, 11 1/4. 7x to the power of 6, again, add 1 to the power, divide by the power, and the 7's cancel. We're going between minus 4 and minus 3. When you're looking at all these, generally the larger number is on top of our in our integration. Not always the way, but generally you'll see it that way. And we'll look at questions later on where we don't have it there and what we can do to manipulate our equations there. So we substitute our values in, minus 3 and minus 4, do our calculations, and it gives us 14,197. Large number. They're not always that large, but it's possible to get them that large. 4 minus 4x squared integrates to minus 4x cubed over 3. Between 2 and 3, we sub 3 in, we sub 2 in, and we're looking at all the positives and negatives, so be really careful. It gives us that negative value there. 10, we're looking at we're going to use the rule where we use that to the power of 1. You can integrate them separately and it'd still work, but this is just applying the rule with the brackets in this case. We add 1 to the power, we divide by the power as well as the coefficient of x. So we're using that rule there. We're going between 2 and 7, so we substitute 7 in, get our calculation, substitute 2 in, get our calculation, and it comes down to 65. Now you could have done all the calculation at that stage to get down to 65. That wouldn't be a problem because you can throw that all on the calculator. So be really careful, subbing the values in, making sure you're using the calculator correctly, watching all your positive and negative signs, and also the correct use of all the rules of integration.